It was a long break, but now I continue to record lectures for you, and today we're going to talk about rendering in Houdini, and default render engine in Houdini called Mantra, and you can find it in Alt, hit Tab, and type Mantra. So this is Houdini default render engine. So to start rendering, we need to create something in the scene. As you can remember, we can click, hold and click Control and click on a grid to put it on the center of the world. And let's create few more objects like this. So something pretty simple. So, and now we have just objects, and we have no lights in the scene, as you can see, and we have no camera. So first of all, we need to create some light. For example, if I want to make a light which will be on the same position like now, I go to Lights and Cameras, select Spotlight, hold Control and click. So now you see that my viewport is changed, and here it says Spotlight. So yeah, so we created a spotlight. The default values of the light is pretty simple. We have light intensity, light color, light type. So I can change it to line, grid, disk, and so on, so on. So I will keep it as point. And here we have spotlight. I'll show it while we render, and a few different options. Okay, but first of all, let's try default values. So I created light. Let's make a camera. So I zoom in a bit and click here and new camera. So now I have camera and light, and now we're ready to render. To do this, we need to switch to render view here on top, and it's black. Well, it's fine because we haven't pressed render button yet, but here we can change the mantra node. Currently we have only one, which is called mantra 1. You can check your nodes here. It's mantra 1. And we have cameras. So let's click camera 1 and hit render button. Scene is generated, and here is our scene. Well, shadow is black, light is pretty strong, and yeah. So let's click pause, and by clicking on this little button, I can split my work area, so left and right. All right, and it's just more comfortable to have two fields. Okay, here you can see I have a red border. It's a render region of the camera. So for example, if I do it like so and hit render, it will render just small area. All right, so let's bring it back. All right. So what do we have? Let's talk about light first. And the spotlight is the simplest light we have, and I can change light intensity to make it brighter. Okay. Light color, I can set it to something like this. And we see that it's changed the color, but it's not the color of the material, it's a light color. Okay, so let's bring it to default. Shadow, we have ray traced shadows and no shadow. So as you can see, if I turn no shadow, the image becomes really flat. And depth map shadow, so we can store them on the hard drive, and this can be a time saver But again, ray traced shadows is more advanced and provide more different features. All right, so this was a spotlight. Let's create one more light, like area light, something like this. And you can see that area light provides more soft shadow. It's more natural than spotlight. And you can change shadow color. And normally it's not nice to have absolutely black shadow. We need to have some color. Well, at least something like this. It's not absolute black. Well, at least mathematically it's not black. Okay. So this is a simple render. Let's talk about Mantra engine features. Not features, but options. Here we have render and render control buttons. If I hit render control, I can set parameters. I actually have no idea why they made this, because it's doing absolutely the same stuff like you can do here. So just let it be. Okay, in Properties tab we have Output, and the output picture is the first field you can find. So when it stands IP, it means interactive, and if I change it to non-interactive, it changed to MD, and if I hit render, this will open the window mplay and show my image here. Okay, probably some issues, but you see it works. So okay, let's bring it back to interactive. Output device is basically the image format, so you can change, you can choose whatever you want. And the Houdini peak format is one of the default formats for Houdini. TIFF is for Maya. OpenXR is a really nice format. It's non-compressed and keeps all layers in one file, which is really handy if you're going to compose a nuke. PNG is also uncompressed. JPEG, well, everybody likes JPEG, but it's crap. And RAT, random access texture, is also default format for Houdini. It's somehow optimized for it, so you can open really huge images without performance drop. Okay, pixel filter, Gaussian 2x2. For example, if you select 3x3, it should be a bit smoother. So on interactive it doesn't work, but on non-interactive output it works. So it basically tells how many pixels you want to blur by. So 2x2 is default. And so you see the difference. All right. Sample filter, quantization. Well, this is pretty advanced options, so I personally have no idea about how it works, but once I need it, I will investigate this. Okay, render. Next tab is render tab, and here we have render engine. By default, it renders in ray tracing, which is kind of slow and expensive, but provides one of the best results. We can switch to micro polygon and render. Something wrong? Well, it's always happens like this. It works when you're preparing this, but it doesn't work when you're showing this. I forgot to switch it back to interactive. Okay. Hmm. Oh, and the reason why it doesn't work is because of this. So here you can switch to active render, or if you click on this photo camera button, it's like making a snapshot of the screen, so you can compare it later to what you had. And it wasn't working because it was standing on the snapshot, not on active render. So if I click on active one, the image will update. Okay, so ray tracing, micro polygon. So it's really hard to tell difference. Well, actually, there is no difference because this scene is pretty simple, but the difference will appear when it's time to render caustic or something else pretty difficult and advanced. Okay, so micro polygon rendering, micro polygon physically based rendering, all of them are pretty nice, and I actually prefer to render PBR, but sometimes I have to switch to ray tracing when, for example, I have some refraction, and so on. Okay, and photon map generation. This one stands for generating photonic maps, for example, for caustic or global illumination. And this one is using for caching this to disk. So I will show it a bit later, but for now, let's go back to ray tracing. Okay, the tile size is basically tells how big this bucket should be. So it's pretty fast now. Yeah, so okay, this one is controlling the size. The bigger the tile size, the faster rendering, but again, it takes more memory. So be careful if you have not much memory. So then it's better to use like 16 or 32. So yeah, 16 is default. Use max processors. Um, this one is on by default, but for example, if you want to have control about how many cores to use, you can turn this off and set this manually. So now you see I use just one thread, and therefore rendering is quite slow comparing to this. Okay, cache limit is you tell how much memory you can use, the Houdini can use for rendering. Okay, sampling is the next step. And first, let's talk about pixel samples. But let's make something more difficult in the scene, or at least let's apply some shader, more advanced, more difficult shader, and let's say glass. And you can apply materials directly in the render result or in viewport. So if I drop it here, you can see that my result, my material is replaced here. And the render time was increased. Okay, this is what we need for testing. I will zoom in camera a bit so we can better see the difference. Okay, and let's go back to mantra in out, mantra, sampling, and pixel samples. By holding shift and dragging mouse, I can select a small render region, so it can render really fast. So let's select something like this. Okay, yeah, 64, 1. Okay, so by default it stands 3 by 3 pixel samples, but to make more clear image, for example, like here, for example, you can see that there is a lot of noise. I can set 6 by 6, and render time will increase significantly, but the noise will be decreased. Okay, and let's compare. So you see the graininess of the noise become smaller, and image is just clearer, more clear. And if I set something like, let's say 20, this will render really long time. And I will make a small pause for now, and when I come back we can see the difference. So this took me about a minute or something like this to render it, and this was on pixel samples 20. I just forgot to make a snapshot on sample 6, so this was on 6 and this is 20. I'm not sure if you can see it, but yeah, the difference is pretty huge. Okay, but this is not only the way to improve the quality, and as you can understand, the rendering on pixel samples 20 by 20 is pretty expensive, and there is another way to do it, and this way called noise level. So if I set instead of 0.05, I switch to, okay, let's make a snapshot. So this is on 6 by 6 and 0.05. If I switch to 0.01, this will be also long, but not that long as rendering on 20 by 20, and the result will be pretty decent. Okay, and this image is rendered by 6 by 6 and noise level 0.01, and this one was rendered on 20 by 20 and default noise value. So difference is here, but this is not that significant, and render time is, this one is faster. Oh, and by default Houdini doesn't show the render time, and to make it to show it you need to go to main tab, and here in comment, instead of mantra, you need to select verbose output, and this will create a Houdini console. I'm not sure about Mac, but probably this will show something like this on the Macs too. And here we can find the render time and the memory which has been used for rendering. And 46.31U is user time, which Mantra has spent to render your image, and 2.96 is system time, which has been spent by system for everything. So I think this time is more relevant, and this must be in seconds. So let's check. Yeah, okay, user time is more correct. It's around 14 seconds. Yeah. So this was a 14 seconds, and if I set noise level back to default value, then I get way faster, just 5.9. Okay, let's minimize this. Here also you can find the volume quality, which is relevant for rendering volumes, and this works like like a voxel multiplier. So you can read about this just by holding it over. And shadow quality and stochastic transparency, if I set to 1, it just controls the transparency quality. The more samples I put, the more clear image I will get. But again, everything is about render time. So let's bring it back to 4, and this one to 3x3. Here also we can find the enable depth of field, so Mantra can render it immediately with depth of field. However, it's not the proper way to do it, because if you decide to change depth of field, you can't do it. So the best way to render is zdepth pass and do it on compose later. I will show you how to render with passes, but just for now let's turn this off. And motion blur, currently we have no motion blur because I have no animation here, but let's do a simple animation. Object, sphere. So let's say it starts from here, and set keyframe, and finished here. Commit change. So now I have simple animation, and let's put it somewhere here. Let's go back to Mantra, hello motion blur, and let's render. So now you see that Mantra renders it with motion blur, and it takes 2 frames, like this one, and blends it. And this is controlled by xform time samples. So if I set 3, this will give me a better result, but will be a bit slower. If I set to 6, this is the best one I can get. So, okay, this one with 6, and this one with 2. It's a little change in the noise, but not that significant. Okay, and geo samples. Well, the changes are really small, and by changing shutter offset, I can control the when the motion blur starts. So, for example, now it's shutter offset -1, and this is 1. So the difference is like this. I think this option is for fine tuning. Okay, let's turn this off. Shading, here you can control how many time reflect ray will bounce and refract limit, and so on. Gamma space, linear. Well, it's the scene is pretty simple, so I can show the difference. But normally, it's recommended to render in linear because it's better for compositing. And if your image is output in linear workspace, then you won't have strange mathematics and so on. So it's better to use a linear. Dicing, Well, this have a shading quality multiplier, but me personally can't find the difference in quality. So if I set to 0.20, like one quart, and 3, um, nothing really changed. Just a bit of noise, but the render time is changing really much on difficult scenes. Okay, so it's almost all about Mantra node. Here you can choose also the frame range. So currently it's set to render any frame, so it's render the current frame here, number 4. But I can set it to frame range and select a frame range and hit render, and this will render for me the whole sequence. Okay. That's basically all about Mantra engine. Well, here we have force object, candidate object. So, for example, if I select this, the candidate objects, I can select which objects I want to render. So currently it selects all of them, everything I have in a scene. But for example, if I turn on only this, so I can render only my sphere, and the reflection will stay here. Or, for example, just box. Okay. I can exclude any objects I want, any object I want, by doing it like this. And I need to know the object name. So sphere object 1, like so. And I hide my sphere. But there is a special field for this, exclude objects. So let's render it again. And select exclude. So I can hide any objects I want. Alright. The same about lights. So for example, solo light. This will render only spotlight because this one is selected as solo. And on the candidate light, I can choose just any light I want to render. Alright, like this. Force lights and force objects is stand for example, I have some hidden objects, but if I put it to force lights or force objects, this will render it. So let me show you. So here is my default render, and all objects are shown. And let's say when I was working, I decided to hide my sphere object. And if you select any object, you can find the render tab here. And here you can see the display field. So let's say I decide to hide this object from scene, and I can't see it in viewport, and I can't see it in render. And after a long working day, I forgot to unhide it, and we need to render. So just to make sure that everything in the scene will be rendered, I can select force objects and select all of my objects. And this will override my display option. So this is pretty useful. Or for example, I just want to test how it looks, but I don't want to change anything in the scene. So That's how it works. The same about lights. If I have some hidden light, I can put it here and this will be rendered. Okay, let's bring it back. And let's talk about options of the objects in terms of rendering. Okay, so let's select our sphere. Render option. We already know about display. And here you can find a phantom checkbox. If I click this will hide the object by itself, but the shadow and caustic will be here. This one is actually the fake caustic, and in a few minutes I will tell you how to render actual caustic, which is really expensive but looks really nice. Okay, let's turn off phantom. Here we can choose display as centroid, point cloud. This mainly affects the viewport, not the rendering. And render polygon as subdivision mantra. This sometimes helps to increase compatibility of the mesh. For example, if you import your geometry from other 3D packets, it can have some issues with normals or something like this, and this option can really help sometimes. Okay, matte shading. This creates just mask for the object. So like this. Really useful for compositing. And shadow is here, caustic is here. This is just black. Ray trace shading. Well, this forces ray tracing instead of micropolygon. So for example, if you have a micropolygon selected in Mantra engine, this will like override this feature. Okay, let's bring it ray tracing back. Okay, and then geometry tab. Few different options. Backface removal. So this will work like this. And since this one is a transparent object, the result is like a thin sphere, while this one looks like a thick ball. All right. Wireframe color. Well, this one is useful for sphere object. I need to change to Polygon. Like so. And wireframe color must control it here. Yep. So it's like color coding like this. Alright, but this one is just very simple render, and Mantra is really advanced render engine. It allows to render global illumination, caustic, and all other nice things, which is really slow, but looks really great. And to see all these features, let's apply new materials to our objects in the scene. And to do this, let's go back to shop. And here, instead of glass, let's delete glass for a moment. Let's create two clay, which you can find here. Click on this button. Galleries, General, Clay. to clay material, and let's assign first to the sphere, second to the box, and this should be enough. If you select clay, you can find reflectivity, roughness, base color. For now, let's change just the base color. This one will be red. And this one will be blue. Oops. Like so. Currently, we have no global illumination because you see there is no color bleeding. To turn on global illumination, let's go back to object level. And first, I will change my sphere back to primitive because I have these angles. Alright, something like this. Okay, let's turn global illumination. To do this, let's hit Tab and type light template. And let's call it Jai. It's nothing fancy here, not many options. But the one we're looking for is under Render tab, Shaders and Light Shader. So we need to create a light shader and connect it to this field. And this shader must be created under Shop context. So let's go back to Shop, hit Tab and type Global Illumination Light. That's one we're looking for. Alright. And let's go back to GI, select here, apply. Alright. So now we're rendering GI. No, we're rendering Ambient Occlusion and not correct Ambient Occlusion. To render proper GI, we need to go back to the shop, select GI Light, and in Irradiance style, change Ambient Occlusion to full Irradiance. Alright, and rendering is become slower. And now you can see there is color bleeding, bluish, reddish. Right, I rolled back a bit because of some issues with rendering. So to make it look better, or to make it more noticeable, I will turn off the light, one of the lights. So now you can see the blue on the ground here and red around here. So, and in the light we have attenuation options, and by default it stands no attenuation, but for physically correct image we need to turn it physically correct. The light will decrease its intensity by physical law, and therefore intensity must be bigger. Well, maybe too much. Okay, let's see how it looks. Yeah. For example, if I change the clay color to green, yeah, it's a lot of color bleeding. Okay, this is global illumination. Pretty render time expensive. But here we have few options. For example, if I change the switch on use ray samples, pay attention to rendering time. You can see it's really slow. If I turn it on, the rendering is really fast. This, because it uses a different calculation method, gives a really rough result. but this should be enough for preview. Adaptive sampling is the Houdini choose by itself where to put more samples, where to put less. And if you want to render in ray samples, then you need to increase the pixel sampling in the Mantry engine. So, for example, now it's rendered 3 by 3. Let's make a snapshot. Go back to Mantry and change pixel sample to something huge, like this. Render time is slow again, but image become really clear. So you see the difference. Alright, switch it back to sampling quality because I can set 64 for example, and this will give me a still clear image, and render time is pretty nice. I can set max ray distance. This is like a distance for a ray which it can travel. So if I set to something really small, you see that color bleeding goes like this, which is unnatural. And by increasing distance, okay, if I set something really huge, then rays will hit again, and again, and later it will go outside to somewhere. So then turned off, and that's okay. Also, you can attach environment map, which will affect your image really significantly. And to do this, you can click on this button and select some image. Here, by default, Houdini have some few nice images, and let's select, for example, Dosh DH something. I don't know, this image, and let's apply it. And you see that it changed the color. Oh, and if you click while it's rendering, if you click on some place, this will pay attention to this first, and once it's done with this area, this will render the whole image. And this is pretty useful. For example, if you want to see some special place first, and don't worry about the rest of the image. Okay, background color. It works like this. Well, if I clear my environment map, we can see it better. So this works like this. It's basically can sucking up the light. Like so. Alright, so this was the global illumination. Here we have photon file. We can choose one, but currently we have no photonic maps. Okay, another option we can get from global illumination. In the irradiance style, we can choose Ambient Occlusion, Hit Render, and now we have our Ambient Occlusion rendered. It renders with color, so that's not really what we want. So let's apply new clay, the gray one. And now you can see that we have ambient occlusion, but again, on ambient occlusion there shouldn't be a shadow. So therefore, let's go back and turn off all the lights. Now this is correct ambient occlusion. Or I can even clear this. Well, it's not a huge difference, so to have a clear clay is enough. And you can change it. So you can render it as you want. Or to default. And the sampling quality here, again, it works really how it should. So if I set the lower sampling, this will give me a faster result but dirty image. Something really small, like this. Or even so. And 128 will give a pretty clear result. So 1K is really slow, but you get the idea. You see there is almost no noise comparing to 32. Yeah. All right. Let's bring it to default. And this is ambient occlusion. No irradiance, for example, transparent ambient occlusion. Well, this should work with glass material, I guess. Yeah, so I can render ambient occlusion and have the transparency on this. Like so. So this was a part 1 of rendering. On the next part, I will talk about how to render with layers. So you can output ambient occlusion, GI, caustic on different layer and then compose it. Also, I will tell how to render caustic, and we'll talk about um, material setup, because Mantra mainly use Mantra surface, which is pretty strong shader, and it's universal. You can set any parameters here and basically mimic the different materials. So yeah, let's talk about this on next lesson. Thank you for watching. See you next time.